So for those of you who are so into using the formula to solve a differential equation, in the IB Black Book, they have mentioned it somewhere in that unit. So knowing how the integrating factor can be obtained using this equation here, and knowing how this integrating factor is actually part of your product rule, part of the terms on the left hand side that goes with your product rule. And as you multiply this integrating factor by y, you can actually come up with the explicit equation for y using this crazy expressions here. But to be honest with you, I wouldn't use this formula at all. I would rather do it one step at a time and solve for y slowly. Using this formula, yes, it will give you the answer in one single step, but you're going to deal with different integration at different time. And as this equation becomes more and more complicated, it is prone to more mistake. So for the next equation, I will use this one. I will solve this equation one step at a time and try to get rid of the 3x for now. As I divide 3x to the other side, this equation turns into y prime plus -1 over 3x of y equals ln x plus 1, or technically 1 plus ln x. Put it this way to avoid any confusion. And now I can find the integrating factor by using e to the power of this, -1 over 3x dx. And that -1/3 is a constant. As I take it out and integrate this, that will give us ln x. E to the -1/3 ln x. And using the property of logarithm, this part goes to the exponent. And as you have base e and ln, this whole thing will simplify to this. That means as I multiply this new term to everything, we will now be ready to solve this differential equation. So the left hand side, which would actually came from product rule involving this term and that term, will now combine to give us this times that. And on the other side, I can simplify this into 3x cube root of x. Don't know if it would help, but it looks easy to deal with. And now I can integrate this. Integrate this with respect to x. And integrate this with respect to x. Looks really complicated to integrate on the right hand side. Well, looking at the right hand side, it definitely looks really complicated to integrate, but we're going to start with use substitution for now. But first of all, on the left hand side, this is what I'll be getting. And on the right hand side, as I integrate this, I'm going to break this up into two parts, having 1/3 and x to the power of 4 over 3, or technically -4 over 3. for the exponent. So that's one part. And for the second part, I will have 1/3 1 over x. Well, I will put 1 over x in the middle. X to the negative 1/3 1 over x and non-x dx. There is a reason why I would prefer this way, because I'm going to let this be my u. Let u be ln x, and that means du equals 1 over x dx, which means I have this and that way. This will be u. But what about this term at the front? What about this part here? This term, I'm going to use the u substitution that we had earlier and rearrange it. du equals x. And that means if I have negative 1/3 for the exponent, that means this one will also come with negative 1/3 in the exponent. And that means on the right hand side, first of all, we know how to integrate the first part here. We add 1 to the exponent and then divide it by negative 3. Divided by negative 1/3, which means times by negative 1/3, plus here 1/3 at the front. We are going to integrate this negative 1/3 of u, and then we have 1x ln x dx. That simply turns into u du. Now hopefully you find this second part familiar enough that you know what to do. This is a very typical equation that involves x dx dx, and you can integrate this part using integration by part. So here, after you've set up your integration by part, well, instead of using u and dv and things like that, I'm going to use other variable. I'll let a be u and db equals the rest. I need more space. Negative 1/3 of u du. So dA equals du and b equals negative 3e negative 1/3 of u. And that means here, the first part, that simplifies to this, plus 1/3, and we will have uv minus v du. Well, technically, this times that, negative 3u e to the negative 1/3 of u minus v du. So that turns into a plus. Integrate negative 1/3 of u du. Now make sure you don't forget the u substitution we had earlier. For all the u that you see on the right hand side, they are actually ln x. So here, negative x, negative 1/3, plus 1/3, negative 3 ln x times e to the negative 1/3 of ln x. Looks complicated. And then as you integrate this part, we will still end up with e to the negative 1/3 of u, or once again u equals ln x, and as you divide it by negative 1/3, we need negative 3 here, and plus c. Let me turn this u into ln x. So now, using the initial value, then we go back to the beginning with x equals 1 and y equals 0. When we have x equals 1 and y equals 0, the left hand side will then be 0. And when x equals 1, that's negative 1. And here 1/3. When x equals 1, that will be 0, turning the whole thing into 0. So that would just give us negative 9. 3 times negative 3 equals 9. And when x equals 1, that turns into 0, e to the power of 0 equals 1. Plus c. So that means we have the constant term here. That will turn into 1 minus 3e. And that means if you have 1 minus 3e for the plus c, 1 minus 3e, then solving for y, you will now have y equals this whole thing divided by this, or technically now having a positive exponent. So there you go. This will be the particular solution for your differential equation. Now on your IB exam, unless they ask you to simplify your answer, you can actually leave your answer this way. You don't have to simplify your answer unless you're told to do so.